Your smartphone, your car's GPS, even the concrete beneath your feet. What if I told you none of these are truly modern inventions? The brilliant minds of ancient civilizations imagined them first, centuries or even millennia before our time. Today, we're diving into 50 jaw-dropping historical discoveries that were so far ahead of their era, they'll make you question everything you thought you knew about human progress. From a 2,000-year-old computer that mapped the stars to self-healing Roman concrete that still baffles scientists, these are the forgotten masterpieces of ingenuity. By the end of this journey, you'll see history not as a straight line, but as a spiral where genius ideas vanish, only to be rediscovered centuries later. So buckle up, we're about to uncover the secrets of the past that were light years ahead of their time. Now let's turn our attention to the very first discovery on our list, one that rewrote the history of technology. Picture this: in the early 1900s, sponge divers off the coast of a tiny Greek island stumbled upon a corroded bronze artifact in a 2,000-year-old shipwreck. At first glance, it looked like a lump of rust, but when researchers carefully examined it, they realized they were holding what many now call the world's first analog computer. This remarkable device, known as the Antikythera Mechanism, was no simple tool. Inside its wooden casing lay an intricate system of at least 30 interlocking bronze gears, each precisely calibrated to track the movements of the sun, moon, and planets. Imagine a clockwork universe in the palm of your hand. This mechanism could predict lunar eclipses, chart the positions of celestial bodies, and even account for irregularities in the moon's orbit. What's truly astonishing is that nothing even close to this level of engineering sophistication appeared again until medieval Europe's mechanical clocks over 1,400 years later. The genius behind this device remains a mystery, but historians believe it may have been linked to legendary thinkers like Archimedes or Hipparchus. What we do know is that the Antikythera Mechanism proves ancient Greece had a grasp of astronomy and precision engineering that rivals our modern tools. It's a humbling reminder that the past wasn't just primitive sometimes, it was centuries ahead of its time, and this is just the beginning of our journey through history's hidden marvels. Moving from the intricate gears of ancient Greece to the sturdy foundations of Rome, our next discovery is something that quite literally held an empire together. While modern concrete crumbles after a few decades, the Romans built structures that have stood strong for over 2,000 years, like the Pantheon, with its massive dome still intact today. The secret, a revolutionary material that could almost be called self-healing. Roman concrete wasn't just durable, it actually repaired itself. Modern scientists discovered this when they analyzed samples and found tiny cracks filled with mineral deposits. Turns out, the Romans mixed their concrete with volcanic ash from the region of Pozzuoli, creating a chemical reaction that allowed new crystals to form in fractures over time. It's like the material had a built-in repair kit. What's even more fascinating is that researchers have only recently cracked the code to replicating this ancient marvel. Laboratories are now experimenting with similar volcanic ash blends, hoping to create modern concrete that could last centuries without maintenance. Imagine bridges or skyscrapers that strengthen themselves instead of deteriorating. The Romans didn't just build for their time, they built for eternity. And as we'll see, their ingenuity was far from the only example of ancient engineering that puts our modern tech to shame. Now, let's shift our focus from the sturdy structures of Rome to a far more mysterious artifact, one that might just rewrite the history of electricity. In the sands of ancient Mesopotamia, archaeologists uncovered something that shouldn't have existed: the Baghdad Battery. These unassuming clay jars, dating back over 2,000 years, contain iron rods and copper cylinders arranged in a way that eerily resembles a modern battery. When scientists reconstructed these jars and filled them with an acidic liquid like vinegar or grape juice, They produced a small but measurable electric current, enough to power a simple light bulb or even electroplate metal. The big question is, did the ancients actually harness electricity, or was this just a lucky accident? Some theories suggest these batteries could have been used for medical treatments, religious rituals, or even gilding objects with thin layers of gold. Yet, skeptics argue there's no definitive proof they were used as power sources. No wires, no devices, no clear records, but here's what's undeniable: the design works. Whether by intention or coincidence, these jars prove that the basic principles of electricity were within reach centuries before Galvani and Volta made their discoveries. It's a tantalizing glimpse into what might have been an ancient technological revolution lost to time. And as we'll see, this isn't the only example of forgotten innovation that challenges our assumptions about the past. Moving from the enigmatic Baghdad Battery to another ancient marvel, let's explore the legendary blades that struck fear into the hearts of warriors: Damascus Steel. For over 1,000 years, these Middle Eastern swords were renowned for their incredible sharpness, flexibility, and those mesmerizing swirling patterns on their surfaces. But what made them so special? Modern science has only recently cracked the code behind their legendary strength. The secret lay in the unique forging process. Blacksmiths in regions like Syria and Persia used a type of steel called woots, imported from India, which contained trace amounts of vanadium and other rare elements. By repeatedly heating, folding, and hammering the metal, they created microscopic carbon nanotubes, structures so advanced that scientists didn't even know they existed until the invention of electron microscopes in the 20th century. These nanotubes gave the blades their extraordinary ability to hold a razor-sharp edge while remaining flexible enough to bend without breaking. But here's the twist: the exact technique was lost by the 18th century. Some theories suggest the original ore sources dried up, while others point to the disruption of trade routes or the fading of closely guarded artisan secrets. For centuries, attempts to recreate Damascus steel fell short until nanotechnology revealed its hidden genius. Today, researchers are studying these ancient methods to develop stronger, lighter materials for everything from medical tools to aerospace engineering. So the next time you hear about cutting-edge nanotechnology, remember, the edge might have been forged over 1,000 years ago in a Middle Eastern workshop. And as we'll see, this isn't the only ancient innovation that's found new life in modern labs. Now, let's turn our attention to one of history's most fearsome weapons: Greek fire. Imagine a liquid flame that clung to ships, burned even on water, and couldn't be extinguished by anything medieval sailors threw at it. This was the Byzantine secret weapon, a technological nightmare that helped them dominate naval battles for centuries. The exact recipe remains a mystery, lost to time like so many ancient innovations, but medieval accounts describe its horrifying effects: flames that roared across the waves, igniting enemy fleets in seconds. Some historians believe it was a volatile mix of petroleum, quicklime, and possibly even pine resin, creating a sticky, napalm-like substance. What made it truly terrifying was its ability to keep burning on water, forcing enemies to either jump ship or face a fiery death. Modern scientists have tried to crack the code, with theories ranging from pressurized siphons to secret chemical additives. One clue comes from the Byzantine Empire's meticulous secrecy. Greek fire was so closely guarded that only a handful of families knew its formula, and they took that knowledge to their graves. Some speculate it might have included ingredients like sulfur or saltpeter, precursors to gunpowder, giving it that explosive edge. What's undeniable is its impact. Greek fire saved Constantinople from multiple sieges, securing the empire's survival for centuries. And while we may never know its exact composition, its legacy lives on in modern incendiary weapons, proof that some ancient innovations were as deadly as they were ahead of their time. From fire that defied water to another ancient marvel, let's journey next to ancient China, where an ingenious device predicted earthquakes centuries before modern seismology. Shifting our gaze from the fiery seas of Byzantium to the imperial courts of ancient China, we encounter a different kind of marvel, one that didn't destroy but predicted. In the year 132 during the Han Dynasty, a brilliant astronomer and inventor named Zhang Heng unveiled something extraordinary: the world's first seismoscope. Picture an ornate bronze vessel nearly 6 feet tall, adorned with 8 dragon heads, each clutching a metal ball above the open mouths of 8 bronze frogs. This wasn't just art, it was a machine that could sense earthquakes hundreds of miles away long before the ground began to shake. Here's how it worked. When an earthquake struck, even faint tremors traveling through the earth would disturb a delicate pendulum hidden inside the vessel. The movement would trigger one of the dragons to release its ball, which would clatter into the frog's mouth below, not only signaling the quake's occurrence but also pointing toward its direction. Historical records claim it once detected an earthquake in what's now Gansu province, over 400 miles from the capital, days before messengers arrived with news of the devastation. Modern scholars still debate the exact mechanics. Some suggest the pendulum theory, while others propose it used a system of inverted levers or even liquid mercury to detect vibrations. What's undeniable is its sophistication. Zhang Heng's device predated European seismology by over 1,500 years, and its design principles echo in today's earthquake early warning systems. The seismoscope wasn't just a scientific breakthrough, it was a lifeline. In an era when earthquakes were seen as divine omens, this invention offered emperors critical time to send aid or prepare defenses. Yet, like so many ancient wonders, the original was lost to history. Only reconstructions based on fragmentary texts hint at its full genius. From predicting the Earth's tremors to another leap in ancient innovation, let's now explore how Viking sailors might have harnessed sunlight itself to navigate the open ocean. Now, let's set sail from the earthquake-predicting dragons of ancient China to the misty waters of the North Atlantic, where Viking explorers faced a different kind of challenge, navigating under skies so thick with clouds that even the sun seemed to vanish. Imagine being a Norse sailor around the year 900, steering a longships through fog and overcast days with no compass or clear landmarks. How did they do it? The answer might lie in a seemingly ordinary crystal one that could reveal the sun's position even when it was completely hidden from view. Enter the Viking Sunstone, a piece of calcite crystal mentioned in medieval sagas. These translucent stones, when held up to the sky, had a remarkable property. They could filter and polarize sunlight, creating a subtle but detectable pattern of brightness. By rotating the crystal until the light patterns matched, sailors could pinpoint the sun's location behind clouds or even just after sunset. Modern experiments have proven this works. Researchers using calcite crystals in overcast conditions could determine the sun's direction with an accuracy of within 1 degree. But here's where it gets even more fascinating. In 2011, a team studying a shipwreck off the coast of Alderney found a calcite crystal near navigational tools, lending physical evidence to the long-debated theory. And in 2018, scientists recreated Viking routes using sunstones, showing they could have crossed the North Atlantic with startling precision, even during the famously gloomy summers of the Viking Age. What makes this discovery truly ahead of its time? The Vikings were essentially harnessing the physics of polarized light, a concept not formally understood until the 19th century. While European sailors later relied on magnetic compasses, the Sunstone offered something unique, a tool that didn't fail near magnetic north, making it ideal for high-latitude voyages. Yet, like many Viking innovations, the Sunstone faded into legend, only to be rediscovered centuries later by scientists piecing together the secrets of their legendary navigational skills. From crystals that captured hidden sunlight to another ancient marvel, let's turn our attention to the mathematical brilliance of the Maya, whose astronomical observations rivaled even those of Renaissance Europe. Now let's journey from the foggy seas of Viking navigation to the lush jungles of Mesoamerica, where the Maya were mapping the heavens with astonishing precision. While Europe was still navigating by the stars with basic tools, Mayan astronomers were tracking planetary movements with mathematical sophistication that wouldn't be matched for centuries. At the heart of their celestial knowledge was the Dresden Codex, one of the few surviving Mayan books. This fragile bark paper manuscript contains tables so precise they could predict the movements of Venus down to the day, calculating its 584-day cycle with an error margin of just 2 hours. Imagine that a civilization without telescopes, using nothing but careful observation and complex math, could forecast Venus's appearances centuries in advance. They even accounted for the planet's irregular motions, adjusting their calculations in ways that modern astronomers later confirmed were spot on. But the Maya didn't stop at pen and paper. Their observatories, like the iconic El Caracol at Chichen Itza, were architectural marvels designed to align with celestial events. The spiral tower's narrow windows perfectly frame Venus at key points in its cycle, while other openings track solstices and equinoxes. This wasn't just stargazing, it was a full-blown scientific operation, blending astronomy with agriculture, religion, and even politics. Kings used these celestial predictions to time coronations and wars, believing the gods communicated through the planets. What makes Mayan astronomy truly ahead of its time? While European scholars were still debating whether Earth was the center of the universe, the Maya had already mapped retrograde planetary motion, the apparent backward movement of planets in the sky, and incorporated it into their calendars. Their long count calendar, spanning thousands of years, was more accurate than the Julian calendar used in Europe at the time. Yet much of this knowledge was lost when Spanish colonizers burned Mayan libraries, leaving us with only fragments like the Dresden Codex to hint at their brilliance. From celestial scribes to another ancient innovation, let's uncover how the Indus Valley civilization mastered urban planning in ways modern cities still struggle to replicate. Leaving behind the celestial wonders of Mayan astronomy, let's step into the streets of a civilization that turned urban living into an art form over 4,000 years ago. In the Indus Valley, the people of Mohenjo-Daro weren't just building homes, they were engineering an entire city with a level of sophistication that wouldn't be seen again for millennia. Picture this: wide, straight streets laid out in a perfect grid, with baked brick houses featuring indoor bathrooms and something almost unthinkable for the ancient world: flush toilets. These weren't just basic pits in the ground. The toilets of Mohenjo-Daro were connected to an elaborate underground drainage system made of brick-lined channels, complete with manholes for maintenance. Wastewater flowed from homes into covered sewers that ran beneath the streets, designed with slopes to keep everything moving smoothly. Some houses even had chutes on upper floors to send waste directly into the system below. It's a level of urban planning that puts many modern cities to shame. But the innovation didn't stop there. The city's Great Bath, a massive public water tank lined with waterproof tar, suggests they understood hydraulic engineering on a grand scale. Surrounding it were carefully designed wells and reservoirs, ensuring clean water access while keeping sewage safely separate. What's truly remarkable is how universal these amenities were, unlike other ancient civilizations where luxury was reserved for elites. Even modest Indus Valley homes often had their own bathing areas and drainage. Archaeologists still puzzle over how they maintained such standards across a city of 40,000 people without centralized authority. No palaces or grand temples have been found, just practical, egalitarian design. Their secret: standardized bricks with perfectly consistent ratios, proving they prioritized function over flash. When later civilizations like the Romans built their famed aqueducts, they were rediscovering principles the Indus Valley had mastered 2,000 years earlier. Now let's shift from these quiet streets to the roar of ancient warfare. where a Greek inventor created a weapon so advanced it would inspire Leonardo da Vinci himself. Now imagine the thunderous roar of ancient warfare, where one of history's greatest minds turned boiling water into a battlefield game-changer. Centuries before gunpowder reshaped combat, Archimedes of Syracuse designed a weapon so ahead of its time that Renaissance genius Leonardo da Vinci would later study its blueprints, the terrifying steam cannon. Picture a massive bronze tube heated until red-hot, then injected with a sudden burst of water. In an instant, the liquid vaporized into explosive steam, launching stone projectiles with terrifying force. Historical accounts claim these cannons could hurl 100-pound boulders, though modern scholars debate whether they were actually used in the defense of Syracuse against Roman ships. What we know for certain comes from Da Vinci's meticulous 15th-century sketches, which describe the mechanism in detail. The design was so convincing that in 2005, MIT engineers built a functional replica. Their scaled-down version shot a cannonball over 1,100 feet using nothing but steam pressure, proving the concept worked spectacularly. The real marvel lies in Archimedes' understanding of thermodynamics centuries before the science even existed. His cannon essentially worked like a giant pressure cooker, harnessing phase change energy that wouldn't be formally studied until the Industrial Revolution. Some historians believe he may have also invented a rapid-fire version called the Architronito, described in Byzantine texts as making a terrifying noise like thunder. While the original bronze cannons likely corroded away long ago, their legacy echoes through history. From Da Vinci's notebooks to modern recreations, this ancient weapon stands as a testament to how wartime necessity can spark innovations that transcend eras. And speaking of battlefield breakthroughs, our next discovery takes us to the Middle East, where surgeons were performing medical miracles while Europe still blamed illness on demons. Moving from the battlefield to the workshop, we encounter a device so elegantly simple yet revolutionary that it foreshadowed the machines that would power the modern world. In the 1st century, the Greco-Egyptian engineer Heron of Alexandria unveiled a marvel that harnessed steam in a way no one had before, the eolipile, often called the world's first steam engine. Picture a hollow metal sphere mounted between two pipes suspended over a boiling cauldron. As steam rushed through the pipes into the sphere, it escaped through two bent nozzles, causing the entire device to spin with surprising force. This wasn't just a clever trick, it demonstrated principles of thrust and rotary motion that wouldn't be fully utilized until the Industrial Revolution, some 1,700 years later. What makes Heron's invention extraordinary is its recognition of steam's potential as more than just hot vapor. While most of his contemporaries saw steam as a curiosity, Heron understood its capacity to perform mechanical work. Historical records suggest he may have even envisioned practical applications, though the abundant slave labor of the ancient world likely dampened interest in labor-saving machines. Modern recreations prove the eolipile wasn't just theoretical. When properly constructed, these devices can reach rotations of over 1,500 revolutions per minute, comparable to many modern engines. Some scholars argue that with metalworking advancements and a culture more inclined toward mechanization, the ancient world might have leaped into an industrial age centuries ahead of schedule. Heron's genius didn't stop there. The same treatise describing the eolipile also outlines automated temple doors, coin-operated machines, and even a primitive wind-powered organ. But it's the spinning sphere that stands as his most prophetic creation, a whirling testament to how close the ancient world came to unlocking steam's transformative power long before James Watt improved the Newcomen engine. As we marvel at this early glimpse of industrialization, our journey takes us next to the high Andes, where another civilization achieved medical feats that still astonish modern surgeons. Leaving behind the whirring steam engines of antiquity, We now journey to the rugged peaks of the Andes, where Inca healers performed medical miracles that would challenge modern surgeons. Between the years 1400 and 1500, these ancient doctors mastered a procedure so precise it defies expectations: trepanation, the delicate art of drilling holes into the human skull. Imagine a healer carefully scraping away at living bone with nothing but an obsidian blade. No anesthesia, no sterile environment, just skill passed down through generations. Hundreds of excavated skulls reveal something extraordinary, not just the holes themselves, but the smooth, healed edges around them. This wasn't ritualistic mutilation. This was survival. Analysis shows an incredible 80% of patients lived through these operations, some undergoing multiple procedures. What makes these surgeries even more remarkable is the tools they used. Obsidian, a volcanic glass sharper than modern steel scalpels when freshly fractured, allowed for clean cuts that minimized tissue damage. Archaeologists have found sets of these blades alongside skulls, some showing wear patterns suggesting repeated use in medical procedures. The Inca understood something modern science only recently confirmed: obsidian causes less trauma to surrounding tissue than metal scalpels, reducing infection risks. But why drill into skulls at all? Evidence suggests these operations treated everything from battle injuries to neurological conditions. Some skulls show fractures from clubs or sling stones, with trepanation likely relieving pressure from swelling. Others may have been attempts to cure chronic headaches or epilepsy. What's undeniable is the anatomical knowledge required: avoiding major blood vessels, recognizing different layers of bone, and knowing exactly how much pressure to apply. Modern neurosurgeons studying these skulls have found something humbling. The placement and angle of the holes often match precisely where we'd operate today for similar conditions. Some patients even show decades of life post-surgery, their skulls remodeling the bone edges as naturally as a healed fracture. As we stand in awe of this ancient medical prowess, our exploration takes an unexpected turn toward the bustling waterways of Imperial China, where an innovation would reshape global trade centuries before the Panama Canal. Now, let's navigate to the bustling waterways of 10th century China, where an engineering marvel transformed trade forever. In the year 984, a visionary official named Cairo Yu cracked a problem that had plagued merchants for centuries: how to move boats smoothly between canals of different heights. His solution, the pound lock, a simple yet brilliant system of gates and chambers that made river transport faster and safer than ever before. Picture this. A boat approaches a locked chamber, its wooden gate sealing shut behind it. Workers then open small sluices, allowing water to flow in or out until the water levels match the next section of the canal. The gates ahead swing open and the vessel glides forward without ever needing to be unloaded. This wasn't just convenient, it was revolutionary. Before pound locks, boats had to be dragged up steep ramps or portaged around obstacles, wasting time and risking damage to goods. What's truly astonishing is how far ahead of its time this innovation was. Similar systems wouldn't appear in Europe until the 1400s, nearly 4 centuries later. The Grand Canal, stretching over 1,000 miles, became the backbone of China's economy thanks to these locks, moving grain, silk, and ceramics with unprecedented efficiency. Modern engineers still admire the elegance of Cairo Yu's design. The gates fit so precisely they needed no rubber seals, relying instead on perfectly carved wood and water pressure to stay watertight. Some original locks remained in use well into the 1900s, a testament to their durability. As we marvel at this ancient solution to a timeless problem, our journey takes us next to the scorching deserts of Persia, where another ingenious invention defied the harsh climate in ways that still impress today. Now, let's step into the blistering heat of ancient Persia, where engineers outsmarted the desert with a cooling system so effective it could preserve ice even in midsummer. Around 400 years before the Common Era, Persians mastered the art of staying cool with 2 groundbreaking inventions: the yakchul and wind catchers. Imagine a massive dome rising from the desert, its thick walls made from a special mixture of sand, clay, and goat hair. This was the yakchul, or ice pit, a natural refrigerator that kept ice and food cold year-round. Workers would collect winter ice from nearby mountains or freeze water overnight in shallow pools, then store it inside the yakchul. The structure's design was pure genius. Its conical shape allowed hot air to rise and escape, while the insulating walls and underground chambers maintained a chilly temperature even when outside temperatures soared. But the Persians didn't stop there. They paired these ice houses with another marvel, wind catchers. These towering structures captured even the faintest breeze, funneling it down into homes and underground qanat tunnels. As air traveled over cool water in the qanats, it dropped in temperature, creating a refreshing draft that circulated through buildings. Some wind catchers could lower indoor temperatures by as much as 20 degrees, turning sweltering rooms into comfortable retreats. What's remarkable is how these ancient techniques still influence modern cooling systems. The principles behind wind catchers can be seen in today's passive cooling architecture, and the yakchul's insulation methods rival contemporary refrigeration. While Europe struggled with heat centuries later, Persian homes and markets enjoyed a luxury many wouldn't experience for ages: a reliable escape from the scorching sun. As we leave the desert's ingenious cooling behind, our next stop takes us to the grand temples of ancient Greece, where another hidden innovation lay beneath the marble floors. Shifting our gaze from the desert's cooling wonders, we arrive in the grandeur of ancient Greece, where engineers tackled the opposite challenge: mastering warmth. Centuries before the Common Era, the Greeks developed a heating system so advanced it would later inspire the famed Roman baths. At the heart of this innovation was the hypocaust, a network of hidden channels beneath floors that transformed chilly spaces into cozy retreats. Picture the Temple of Artemis, one of the 7 wonders of the ancient world. Beneath its marble floors ran a maze of clay pipes and raised pillars, creating an empty space where hot air could circulate. Slaves or servants would stoke a furnace in an adjacent room, sending heat through these channels, warming the floors above. The design was so effective that even the grandest villas and public baths adopted it, offering comfort during harsh winters. What made the hypocaust revolutionary was its efficiency. The clay pipes retained heat for hours, while the raised floors ensured even distribution. Some wealthier homes even extended the system to warm walls through hollow tubes, a precursor to modern radiant heating. The Romans later refined the concept, but the Greeks laid the groundwork, proving that luxury and practicality could coexist. What's fascinating is how this ancient technology mirrors today's underfloor heating systems. The principles remain nearly identical, only the fuel source has changed. While we use electricity or gas, the Greeks relied on fire and ingenuity, yet both achieved the same goal: turning cold spaces into havens of warmth. As we step away from the toasty floors of Greece, our journey leads us to an even more intimate innovation, one that restored mobility and defied expectations. Now, let's turn our attention to an innovation that speaks to the resilience of the human spirit: ancient Egypt's remarkable advancements in prosthetics. Among the most striking examples is the Cairo toe, a wooden prosthetic dating back to between 950 and 710 years before the Common Era. This wasn't just a cosmetic piece, it was a carefully crafted, functional device designed to restore mobility, complete with movable parts that mimicked the flexibility of a real toe. Discovered in a tomb near Luxor, the Cairo toe was attached to the foot of a woman who likely lost her own toe due to injury or disease. What makes this prosthetic extraordinary is its design. The toe features a hinge made of leather strips, allowing it to bend naturally with each step. Modern tests using replicas have shown that it wasn't merely decorative, it provided genuine support, helping the wearer walk more comfortably. This level of sophistication challenges the long-held assumption that ancient prosthetics were purely symbolic or rudimentary. but the Cairo toe isn't alone. Other Egyptian prosthetics, like a 3,000-year-old artificial toe made of cartonnage, a material similar to papier-mâché, further demonstrate their understanding of biomechanics. These devices reveal a society that valued both function and comfort, blending craftsmanship with medical insight. What's truly fascinating is how these ancient innovations parallel modern prosthetic technology. Today, we use advanced materials like carbon fiber, but the core idea remains the same: restoring lost function with ingenuity. The Egyptians may not have had our tools, but their solutions prove that the desire to overcome physical limitations is as old as civilization itself. As we marvel at these early medical breakthroughs, our journey takes us next to the vibrant cultures of Mesoamerica, where another surprising material was shaping lives in ways no one expected. Now, let's step into the lush jungles of ancient Mesoamerica, where the Olmec civilization unlocked a secret that would bounce its way through history, literally. Long before Charles Goodyear patented vulcanization in the 19th century, the Olmecs were already masters of rubber, crafting bouncy balls from natural latex as early as 1600 to 400 years before the Common Era. The process was nothing short of ingenious. They harvested latex from rubber trees, then mixed it with the juice of morning glory vines. This wasn't just a random experiment, it was chemistry in action. The vine juice contained sulfur-like compounds that transformed the sticky latex into a durable, elastic material, perfect for creating everything from balls for ritual games to waterproof coatings for fabrics and tools. Archaeologists have uncovered rubber balls in Olmec sites, some as heavy as 8 pounds, used in games that were far more than just sport. These matches, often tied to religious ceremonies, could last for hours and were played on grand courts, where the high bouncing rubber balls added a dynamic, almost magical element to the spectacle. What's truly remarkable is how the Olmec's rubber technology spread across Mesoamerica, influencing later cultures like the Maya and Aztecs. Their formula was so effective that modern tests show these ancient rubber balls could bounce nearly as well as today's synthetic versions. Imagine that, a breakthrough so advanced it took the Industrial Revolution centuries to catch up. As we marvel at the Olmec's rubber revolution, our next stop takes us to another corner of the ancient world, where metallurgy reached heights that would baffle even modern engineers. Now let's journey to the ancient forges of India, where blacksmiths unlocked the secrets of a metal so extraordinary it would shape the course of warfare for centuries. Between 300 years before the Common Era and 1700 years after, Indian artisans perfected the art of creating wood steel, a material so advanced it became legendary across the ancient world. This wasn't just any steel, it was known as watered steel for its mesmerizing, wavy surface patterns resembling flowing water, but the real magic lay beneath the surface. Wood steel contained microscopic bands of carbide, a feature that gave it unparalleled flexibility and razor-sharp edge retention. Imagine a sword that could bend without breaking and stay sharp through battle after battle, a weapon so superior it became the stuff of myths. The process was as precise as it was mysterious. Craftsmen melted iron with specific carbon-rich materials, often including leaves and wood, in sealed clay crucibles. The slow cooling process allowed the carbon to form those microscopic carbide structures, creating a blade that was both incredibly hard and surprisingly resilient. When these ingots were traded to Damascus, Syrian smiths forged them into the legendary Damascus blades, renowned for their ability to slice through lesser metals with ease. Modern scientists using electron microscopes have only recently unraveled the secrets of wood steel, discovering nanostructures that ancient smiths somehow mastered without any understanding of metallurgy at the atomic level. It's a stunning reminder of how intuition and experimentation could achieve results that even today's technology struggles to replicate perfectly. As we leave the glowing forges of ancient India, our next discovery takes us to a civilization that harnessed the very elements to light up the night in ways that still astonish us today. Turning our attention to the ingenuity of ancient China, we find a civilization that didn't just harness fire, they tamed the very earth to extract its hidden energy. As early as 200 years before the Common Era, Chinese engineers in Sichuan were pioneering techniques for natural gas drilling that wouldn't be matched in the West for nearly 2,000 years. Picture this: bamboo pipelines stretching across rugged terrain, carrying flammable gas to salt evaporation sites. These weren't simple hollowed-out stalks, they were carefully sealed with mud and lacquer to prevent leaks, creating what might be history's first pressurized gas distribution system. But the real marvel lay underground, where workers used primitive derricks and percussion drilling to reach astonishing depths of up to 3,000 feet. The method was as clever as it was dangerous. Teams would raise and drop heavy iron bits, pulverizing rock inch by inch, while bamboo tubes were lowered to remove debris, a process eerily similar to modern cable tool drilling. What drove this risky endeavor? Salt. Sichuan's brine wells often contained pockets of natural gas, which engineers learned to burn off or harness, using the flames to boil brine faster than wood fires ever could. Archaeologists have found evidence of sophisticated wellhead control systems, including valves made of stone and wood to regulate gas flow. Some historical accounts even describe bamboo storage tanks and leather bellows used to direct the gas, early precursors to today's industrial gas handling equipment. What's truly humbling is realizing these innovations emerged without any understanding of chemistry or geology as we know them. Through sheer observation and trial and error, ancient drillers mapped underground gas reservoirs and developed safety practices that kept their operations running for generations. When we flip a gas stove switch today, we're part of a chain of innovation that began with bamboo and brute force in the mountains of Sichuan. As we marvel at these flame-controlling pioneers, our next discovery reveals how another civilization turned the sky itself into a precision clock. Now let's step into the shadow of Mount Vesuvius, where volcanic ash preserved a snapshot of medical brilliance frozen in time. Among Pompeii's ruins, archaeologists uncovered an entire surgical toolkit, over 150 instruments so advanced, some wouldn't look out of place in a modern operating room. The Romans didn't just treat wounds, they perfected the art of precision healing. Take their bone drills, for instance. These hand-cranked tools featured interchangeable bronze bits for different procedures, complete with a guard to prevent overpenetration. Surgeons could perform trepanation, drilling into the skull to relieve pressure, with astonishing accuracy, a technique still used today for certain brain surgeries. But the real showstopper, the vaginal speculum, this gleaming bronze device with its scissor-like handles and adjustable blades, mirrors the design gynecologists use in the 21st century. Pompeii's ruins yielded multiple variants, some with screw mechanisms for controlled dilation, proof that Roman physicians prioritized both patient comfort and surgical precision. The collection reads like a medical supply catalog: bone levers for setting fractures, catheters for bladder relief, even delicate scalpels with steel blades sharper than modern stainless steel. Forensic analysis reveals these tools weren't just for show, where patterns show repeated sterilization in boiling water or vinegar, and some handles bear the grip marks of left-handed surgeons. What's truly remarkable is how these innovations spread across the empire. Identical tools have been found from Britain to Syria, suggesting standardized medical training. The Romans didn't just advance surgery, they systematized it, with instruments categorized by function in medical texts like Cornelius Celsus' De Medicina. As we examine these ancient steel and bronze marvels, we're left with a humbling realization. When a Roman surgeon reached for a forceps, they held in their hands the same fundamental technology that would one day land on the moon in a spacecraft's medical kit. Next, we'll see how another civilization turned everyday observation into mathematical revolution. Now let's travel even further back in time to the dusty plains of Mesopotamia, where a small clay tablet holds secrets that rewrite the history of mathematics. Known as Plimpton 322, this unassuming artifact from around 1800 BC contains something extraordinary, a table of numbers that reveal the Babylonians understood principles of trigonometry over 1,000 years before the Greeks. At first glance, the tablet appears to be just rows of cuneiform numbers, but when researchers decoded its contents, they found 15 perfect Pythagorean triple sets of 3 whole numbers that fit the famous theorem for right triangles. These weren't random calculations. The tablet systematically lists triples where the diagonal of a rectangle relates to its sides with astonishing precision, like 5, 12, 13 or 65, 72, 97. What makes this discovery so groundbreaking is the sophistication behind it. Unlike the Greeks who approached geometry visually, the Babylonians worked purely numerically. Their base 60 system allowed them to calculate with fractions far more accurately than later civilizations using base 10. Some scholars believe they may have even used these tables for practical applications like land surveying or constructing buildings with perfect right angles. The real mystery lies in how they generated these numbers without modern algebra. Recent studies suggest they employed a clever method involving reciprocal pairs and quadratic equations, concepts not formally developed until the Renaissance. This implies Babylonian mathematicians weren't just recording observations but actively manipulating abstract mathematical relationships. Perhaps most humbling is the tablet's purpose. Some argue it was a teacher's aid, proving that advanced math was being systematically taught in scribble schools. Others see it as evidence of an even older mathematical tradition lost to time. Either way, Plimpton 322 shatters the notion that theoretical mathematics began with the Greeks. As we marvel at this 4,000-year-old calculator, we're reminded that human curiosity has always sought patterns in numbers, and sometimes the most profound discoveries come baked in clay rather than carved in marble. Next, we'll uncover how an ancient civilization turned harsh climates into a preservation breakthrough. Now let's climb high into the Andes Mountains, where the Inca civilization turned a simple potato into a survival superfood that could last for decades. Their secret, a brilliant freeze-drying technique called chuño, perfected centuries before modern food preservation existed. Picture this. On the high-altitude plains, nighttime temperatures plunge below freezing, while daytime sun blazes intensely. The Incas harnessed this natural cycle by spreading potatoes across the ground to freeze solid at night. Come morning, they'd stomp on them to squeeze out moisture, then let the sun dehydrate them completely. After repeating this process several times, what remained were lightweight, rock-hard chuño potatoes with all their nutrients locked in, but without the water that causes spoilage. This wasn't just clever, it was revolutionary. Chuño could be stored for up to 20 years, providing reliable food during droughts or wars. The process even improved the potatoes' nutrition by concentrating their calories and making them easier to digest. Some scholars believe this innovation helped the Inca Empire sustain armies and workers, building marvels like Machu Picchu without relying on seasonal harvests. What's truly remarkable is how the Incas adapted to their environment without any modern technology. They observed nature's patterns and created a solution that still inspires food scientists today. In fact, NASA has studied chuño for space missions, proving that ancient wisdom sometimes outshines high-tech alternatives. As we peel back the layers of this ingenious preservation method, we're reminded that necessity doesn't just breed invention, it can also create timeless solutions. Next, we'll step into an ancient temple where worshippers encountered the world's first vending machine. Now, let's step inside an ancient Greek temple where worshippers encountered something astonishing: the world's first vending machine. Picture this. In the 1st century, an inventor named Heron of Alexandria designed a device that dispensed holy water with the drop of a coin. It wasn't just a curiosity, it was a glimpse into the future of automation, centuries before the Industrial Revolution. Here's how it worked. A worshipper would insert a bronze coin into a slot at the top of the machine. The weight of the coin would press down on a lever, opening a valve that released a precise amount of holy water. Once the coin slid off the lever, the valve snapped shut, stopping the flow. Simple yet brilliant. This mechanism used basic principles of gravity and balance, but it was so effective that modern vending machines still rely on similar concepts today. What makes Heron's invention truly remarkable is its purpose. Unlike today's snack or soda dispensers, this wasn't about convenience, it was about fairness. Temples used it to prevent people from taking more holy water than they paid for, ensuring everyone received an equal share. It was a blend of engineering and ethics, solving a practical problem with ingenuity. Heron didn't stop there. His writings describe other automated devices, from steam-powered engines to mechanical puppets, proving that the ancient world was far more technologically adventurous than we often assume. While his vending machine might seem like a small innovation, it laid the groundwork for the automated systems we depend on now. As we marvel at this ancient precursor to modern technology, we're reminded that innovation isn't always about complexity. Sometimes it's about seeing a problem and crafting a clever solution. Next, we'll uncover an even older medical breakthrough hidden in the sands of Egypt. Shifting our focus from mechanical wonders to medical ingenuity, let's travel back to ancient Egypt, where a remarkable discovery reveals just how advanced their understanding of the human body truly was. Imagine a civilization so attuned to nature's clues that they devised a pregnancy test 3,000 years before modern science confirmed its accuracy. The secret lies in a papyrus from around 1350 BC, detailing a method that sounds almost magical. Women were instructed to urinate on bags of barley and wheat seeds. If the seeds sprouted, it meant pregnancy. Simple, right, but here's the astonishing part. In 1963, scientists tested this ancient method and found it worked about 70% of the time. The reason: a hormone called HCG produced during pregnancy actually stimulates plant growth. The Egyptians had unknowingly tapped into biochemistry long before the concept even existed. What's even more fascinating is how they interpreted the results. If barley sprouted first, they believed it indicated a boy. Wheat sprouts meant a girl. Modern science hasn't confirmed this gender prediction, but the fact that the core test held up is mind-blowing. This wasn't guesswork, it was observation refined over generations, a testament to their keen eye for patterns in nature. This discovery challenges our assumptions about ancient medicine. While we often think of it as rudimentary or superstitious, the Egyptian pregnancy test shows a sophisticated blend of empiricism and practicality. They didn't have microscopes or labs, but they had something equally powerful: patient observation and a willingness to let nature reveal its secrets. As we marvel at this intersection of botany and biology, we're reminded that sometimes the oldest wisdom holds unexpected truths. Next, we'll see how another ancient culture turned their gaze skyward, predicting earthquakes with startling precision. Now, let's journey from the fertile banks of the Nile to the imperial courts of ancient China, where another visionary mind was decoding nature's hidden signals. While the Egyptians were reading seeds, Zhang Heng, a brilliant polymath of the Han Dynasty, was studying the skies and the earth in ways that would baffle scientists for centuries. In the year 132 CE, Zhang Heng unveiled something extraordinary: the world's first seismoscope. This ornate bronze device, shaped like a vase and adorned with 8 dragon heads, each holding a metal ball, was far more than decorative. When an earthquake struck, even hundreds of miles away, the tremors would trigger a mechanism inside, causing one of the dragons to drop its ball into the mouth of a waiting frog below. The direction of the fallen ball pointed to the quake's epicenter, but here's what makes it truly groundbreaking. Zhang Heng didn't just build a detector, he proposed a radical theory. He believed earthquakes were linked to celestial movements and imbalances in the Earth's energies, a concept dismissed for centuries until modern geology rediscovered connections between tidal forces, planetary alignments, and seismic activity. In the 1970s, scientists began revisiting his ideas, finding correlations between lunar cycles and earthquake frequency. While his exact mechanisms remained debated, the core insight that the heavens and the earth communicate was eerily prescient. Zhang Heng's work reminds us that genius isn't bound by era. With nothing more than observation and intuition, he bridged the cosmic and the terrestrial, leaving a legacy that still resonates in today's seismology labs. Next, we'll uncover how another ancient innovation played with light in ways that defied explanation for over a millennium. Now, let's step into the dazzling world of Roman craftsmanship, where artistry and science merged in ways that still leave modern researchers in awe. Among the treasures of ancient Rome, one artifact stands out not just for its beauty, but for its mind-bending technological sophistication, the Lycurgus cup. Crafted in the 4th century CE, this ornate drinking vessel isn't just a masterpiece of glasswork, it's a marvel of early nanotechnology. At first glance, the cup appears jade green when lit from the front. But tilt it, and something magical happens. The glass transforms into a deep, glowing red. This isn't some trick of the light. The secret lies in the glass itself, infused with microscopic particles of gold and silver, each 1,000 of times smaller than a grain of sand. Here's where it gets even more astonishing. These nanoparticles aren't just decorative. They interact with light in a way that wasn't fully understood until the 20th century. When light hits the cup, the electrons in the metal particles vibrate at specific frequencies, scattering certain wavelengths of light. This phenomenon, called dichroism, is the same principle behind modern technologies like photochromic lenses and even some medical sensors. What's truly baffling is how Roman artisans achieved this without microscopes or modern chemistry. Scholars believe they accidentally stumbled upon the effect by grinding down gold and silver into fine powders, then mixing them into molten glass. But the precision required to consistently produce this effect suggests a level of trial and error, or perhaps even lost knowledge, that rivals modern material science. Today, the Lycurgus cup sits in the British Museum, a silent testament to Roman ingenuity. It's a reminder that even in antiquity, humans were manipulating matter at scales we once thought impossible. Next, we'll travel to the Islamic Golden Age, where another medical breakthrough was saving sight centuries before modern ophthalmology. While the Romans were mastering light at the microscopic level, halfway across the world, a groundbreaking medical procedure was restoring vision to countless patients. Let's turn our attention to 10th century Baghdad, where physician Amr al-Mawsili pioneered a remarkably precise solution for one of humanity's oldest afflictions, cataracts. At a time when European medicine still relied on rudimentary practices, al-Mawsili developed a technique using a hollow metal needle to safely extract clouded lenses from the eye. His tool, called the hypodermic syringe needle, was a marvel of early surgical innovation. Here's how it worked. After numbing the eye with anesthetic soaked in a sponge, he'd make a tiny incision in the cornea, then insert the needle to gently suction out the cataract. This method wasn't just effective, it was astonishingly gentle compared to the brutal couching techniques used elsewhere, where cataracts were simply pushed deeper into the eye with a blunt instrument. Medieval manuscripts like the Book of Choice in ophthalmology detail his methods with intricate illustrations, showing how this procedure preserved the eye's delicate structure. What's even more impressive, modern ophthalmologists confirm his approach aligns with core principles still used today. Al-Mawsili even documented post-operative care, instructing patients to avoid bright light and recommending herbal poultices to reduce swelling, a holistic approach centuries ahead of its time. Yet perhaps the most telling evidence of his success comes from his own writings, where he boasts a perfect surgical record on soldiers and slaves alike. While we can't verify every claim, surviving texts from Cordoba to Damascus reference his methods for generations, proving this wasn't just theoretical, it was life-changing medicine in action. Next, we'll see how Viking navigators harnessed the power of light in an entirely different way, using crystals to conquer the treacherous North Atlantic. Now, let's set sail into the icy unknown with the Vikings, whose mastery of the seas took them farther than any European explorers of their time. While most medieval travelers clung to coastlines, Norse navigators ventured deep into the Arctic Circle, guided by ingenious tools that blurred the line between myth and science. At the heart of their success may have been the mysterious sun compass, a wooden disc with notches that some historians believe functioned like a primitive GPS. On overcast days when the sun vanished, sagas hint they turned to something even more extraordinary: translucent crystals called sunstones. These weren't just pretty rocks. Modern experiments with Icelandic spar, a type of calcite crystal, show it can polarize sunlight, revealing the sun's position even through thick cloud cover. Picture a Viking captain holding a crystal to the sky, rotating it until light patterns align to point the way like nature's own navigation app. But the real test came in the Arctic's endless summer daylight or winter darkness, where traditional stars and shadows failed. Here, researchers think Vikings may have combined sunstones with twilight boards, horizon mapping tools that tracked subtle light gradients during polar twilight. It's no wonder they reached places like Newfoundland centuries before Columbus, or traded with Arctic tribes as far north as the White Sea. What's truly remarkable? These methods weren't just guesses. A 2013 study proved that using a sunstone on a cloudy day could plot a course within 5 degrees of accuracy, nearly as precise as a modern magnetic compass. And unlike fragile instruments, these crystals worked in storms, freezing temperatures, and even when wet. Next, we'll descend from the frozen north to the sun-baked deserts of India, where ancient engineers solved a very different challenge: harvesting water from seemingly barren earth. Leaving behind the frozen ingenuity of Viking navigators, we now journey to the sun-scorched landscapes of ancient India, where survival depended on outsmarting drought. Here, architects didn't just build structures, they engineered miracles of water conservation. Among the most breathtaking is Chand Bayori, a colossal stepwell in Rajasthan boasting 3,500 perfectly symmetrical steps descending 13 stories into the earth. Imagine a massive inverted pyramid carved entirely by hand, its staircases forming hypnotic geometric patterns as they plunge toward a hidden reservoir. These weren't just staircases, they were a sophisticated cooling system. As temperatures soared above 100 degrees Fahrenheit outside, the lower steps remained refreshingly cool thanks to evaporative cooling. The deeper you went, the more the air temperature dropped, sometimes by as much as 20 degrees, creating natural refrigerators for food storage and community gathering spaces during heat waves. But the real genius lay in their water harvesting. During monsoon rains, the steps funneled every precious drop into the central well, while intricate filtering systems removed silt and debris. In drought years, the stepwell's depth ensured water remained accessible even as other sources dried up. Some wells, like Gujarat's Rani Kai Vav, even featured water gates to control flow and prevent evaporation, a concept modern engineers now study for drought-prone regions. What's astonishing is how these structures doubled as social hubs. Pilgrims rested on shaded landings, children played on the steps, and artisans carved intricate deities into the walls, transforming utilitarian water sources into breathtaking subterranean temples. Today, as Rajasthan faces record droughts, archaeologists are rediscovering these ancient techniques, proving that sometimes the best solutions are waiting centuries underground. Next, we'll climb back toward the light to uncover how the Greeks harnessed fire and mirrors in ways that still baffle scientists. Rising from the shadows of India's stepwells, we turn our gaze toward the Mediterranean, where ancient engineers played with light like no civilization before. The legendary pharaohs of Alexandria, towering over 400 feet tall, wasn't just a beacon, it may have been history's first weaponized mirror. Ancient texts whisper of a reflective device so powerful it could ignite enemy ships miles offshore, a claim that straddles the line between myth and startling possibility. Picture this: at the lighthouse's summit, workers polished a massive bronze disc curved to focus sunlight into a searing beam. On clear days, the mirror's glare would have been visible for 30 nautical miles, but its true terror allegedly came when angled toward invaders. Byzantine chroniclers describe how defenders set fire to ships in the open sea, with flames erupting as if by magic. Modern experiments suggest it's not entirely far-fetched. Using replicas based on Archimedes' proven work with parabolic reflectors, engineers have generated temperatures exceeding 500 degrees Fahrenheit, hot enough to scorch wooden hulls coated in pitch. Yet the real marvel lies in the lighthouse's dual genius. By night, its furnace likely burned lime-rich limestone, creating a chemical reaction that produced an intense, long-lasting glow. By day, the mirror doubled as a navigational aid, reflecting sunlight to guide ships through the treacherous Nile Delta. Some historians propose it even functioned as an early weather station, with the mirror's angles signaling approaching storms to fishermen. What makes this technology truly ahead of its time? The precision required to craft such a mirror would demand an understanding of optics that Europe wouldn't rediscover until the Renaissance. And while debate lingers over whether the burning mirror was real or exaggerated, one thing's certain: the pharaohs stood for over 1,500 years as a testament to Greek innovation until an earthquake finally toppled it in the 14th century. Next, we'll see how ancient farmers revolutionized agriculture with a simple tube. Shifting from the brilliance of ancient optics to the quiet revolution of agriculture, we uncover another marvel of efficiency: the Chinese seed drill. Imagine the backbreaking labor of planting fields by hand, scattering seeds unevenly across the soil. Now picture a simple wooden cart with multiple tubes, each dropping seeds at precise intervals as it rolls forward. This was the genius of Han Dynasty farmers over 2,000 years ago. Archaeological finds and agricultural manuals from the period reveal seed drills with up to 3 tubes pulled by oxen or horses. Each tube deposited seeds into neatly plowed furrows, while a small blade ahead of the wheels broke the soil. The result: crops grew in orderly rows, spaced perfectly to maximize sunlight and nutrients. Historians estimate this method slashed labor by an astonishing 90% compared to traditional hand sowing, but the innovation didn't stop there. Some advanced models even included a compartment for fertilizer, often crushed animal bones or manure, releasing nutrients directly into the soil alongside the seeds. This dual-function design meant farmers could plant and nourish their crops in a single pass, a concept Europe wouldn't adopt until the 17th century. What makes this invention truly ahead of its time? Beyond sheer efficiency, it reflected a deep understanding of plant biology. The Han Dynasty treatises emphasized optimal seed depth and spacing, principles modern agronomy still follows today. While later European seed drills gained fame during the agricultural revolution, their Chinese predecessors had already mastered the technology more than 1,500 years earlier. From fiery mirrors to farming tools, ancient innovations continue to surprise us. Next, we'll delve into the stones of Egypt, where new research suggests the pyramids might hold secrets of man-made concrete. Turning from the agricultural innovations of ancient China, we now journey to the sands of Egypt, where the very stones of the pyramids whisper secrets of lost technology. For centuries, historians assumed the massive blocks of the Great Pyramid were carved from solid limestone and hauled into place. But groundbreaking research suggests something far more astonishing, that the ancient Egyptians may have mastered a form of concrete centuries before Rome perfected it. Recent microscopic analysis of pyramid blocks reveals tiny air bubbles and non-natural mineral distributions, clues that point to reconstituted limestone rather than quarried stone. Scientists have identified binding agents mixed into the crushed limestone, possibly including natron or silica from the Nile's sediments. This geopolymer theory proposes that workers poured a slurry of treated limestone into wooden molds, creating custom-shaped blocks that hardened in place. The implications are staggering. Casting blocks on site would explain how the pyramids achieved such precise fits without mortar. No need to transport multi-ton stones when you can grow them where they're needed. It also accounts for the pyramid's astonishing durability. Unlike modern concrete that degrades over time, these ancient blocks have withstood 4,600 years of desert winds and temperature swings. Perhaps most intriguing is the potential link to alchemy. Egyptian texts describe a mysterious white liquid used in construction, long dismissed as myth. Modern experiments show that dissolving certain salts in water can create a chemical reaction that bonds limestone particles, a recipe that aligns eerily with those ancient descriptions. While debates continue, one thing is clear. If the geopolymer theory holds, we've underestimated the chemical ingenuity of pyramid builders by millennia. From poured stone to celestial navigation, our next discovery takes us to the Andes, where Inca engineers defied gravity with woven grass bridges spanning dizzying heights. While the pyramids stand as monuments to stonework mastery, the Aztecs achieved something equally remarkable with earth and water. Picture a city crisscrossed by canals, where lush rectangular islands burst with crops year-round. Welcome to the Chinampas of Tenochtitlan. These weren't ordinary farms, but floating gardens engineered to feed a metropolis built on a lake. The Aztecs crafted Chinampas by weaving reeds into giant rafts, then piling them with nutrient-rich mud dredged from lake bottoms. Willow trees planted along the edges acted as natural anchors, their roots knitting the artificial islands into a stable grid. But the real genius lay beneath the surface. By channeling freshwater through the canals, farmers created a self-fertilizing system. Fish waste nourished crops while plants filtered the water in return. This closed-loop design produced staggering yields. Records suggest some Chinampas yielded 7 harvests annually, growing maize, beans, squash, and even flowers. At their peak, these gardens covered over 12,000 acres, feeding 200,000 residents without plows or beasts of burden. Modern studies reveal their secret. The lakebed mud contained volcanic minerals that slowly released nutrients, outperforming today's chemical fertilizers in sustainability. What makes Chinampas truly ahead of their time was their resilience. When Spanish conquistadors destroyed Tenochtitlan's aqueducts, the Chinampas kept producing. Their decentralized water supply made them collapse-proof. Today, a few surviving Chinampas near Xochimilco still operate, proving the Aztecs' agricultural vision wasn't just productive but timeless. From self-sustaining farms to self-healing roads, our next discovery reveals how Roman engineers built highways that lasted millennia. Now, let's step into the world of ancient automation, where temples didn't just inspire awe, they literally opened their doors like magic. Picture this: worshippers approaching a sacred shrine, and as they near the entrance, the massive doors swing open on their own, as if moved by invisible hands. This wasn't divine intervention. It was the genius of Heron of Alexandria, a 1st-century engineer who built the world's first automatic doors. Heron's design was a marvel of steam power and precision. Hidden beneath the temple floor, a fire-heated altar produced steam that traveled through pipes to a set of counterweights and pulleys. As pressure built, the mechanism triggered the doors to glide apart, creating a dramatic reveal for visitors. When the fire died down and the steam condensed, the counterweights reversed the process, silently closing the doors behind them. It was theater and engineering in perfect harmony. What's astonishing is how closely Heron's system mirrors modern automation principles. His use of thermal energy to create motion predates industrial steam engines by over 1700 years. Recreations by historians prove these doors weren't just theoretical. They worked reliably enough for daily use in busy temples, but Heron didn't stop there. His automated temple also featured moving statues and sound effects, all powered by the same steam technology. Imagine the impact on ancient worshippers experiencing what seemed like living gods at work. While today's motion sensors have replaced steam, the core idea remains unchanged, using energy to create seamless, human-free movement. From self-opening sanctuaries to self-cooling homes, our next discovery unveils how ancient Persians turned desert heat into ice. Now, let's turn our attention to an object so unassuming that for decades it was mistaken for mere decoration. Unearthed in the ruins of Nimrud, the ancient Assyrian capital, lies a small rock crystal disk known as the Nimrud lens. Dating back to around 750 to 710 BCE, this palm-sized artifact has sparked heated debates among archaeologists. Was it an early magnifying glass, part of a primitive telescope, or simply an ornate piece of jewelry? The lens, roughly the size of a modern watch face, is ground into an oval shape with one slightly convex side. When tested, it demonstrates a modest but clear ability to focus sunlight, magnifying objects up to 3 times their original size. This has led some scholars to propose that Assyrian craftsmen might have used it for intricate work, like engraving tiny cuneiform tablets or fine metalwork. Others go further, suggesting it could have been part of a larger optical device, perhaps even an early telescope, but here's where the mystery deepens. The lens was found in a royal storeroom alongside glass and crystal artifacts, raising the possibility it was purely decorative. Assyrian art frequently featured polished crystals as symbols of power, and the lens's slight magnification could have been accidental, a byproduct of skilled lapidary work. Yet, ancient texts from the region mention burning glasses used to start fires, hinting at deliberate optical experimentation. Modern recreations show the lens, while imperfect by today's standards, could indeed sharpen vision for detailed tasks. Whether it was a tool, a scientific curiosity, or a status symbol, the Nimrud lens stands as a testament to humanity's timeless fascination with bending light to our will. From the mysteries of ancient optics, we journey next to a discovery that transformed medicine, where medieval Islamic surgeons pioneered a technique still used today to restore sight. Moving from the realm of ancient optics to the meticulous world of crime-solving, we uncover a groundbreaking text that reads like something straight out of a modern detective novel, except it was written over 750 years ago. In 1247, during China's Song dynasty, a visionary official named Song Sai compiled what many consider the world's first forensic science manual, titled The Washing Away of Wrongs. This extraordinary work didn't just document procedures, it revolutionized how authorities investigated suspicious deaths, introducing methods so advanced they wouldn't be matched in Europe for centuries. Song Sai's handbook reads like a masterclass in early forensic pathology. One of its most striking revelations, the use of insect behavior to estimate time of death. He meticulously observed how flies swarmed corpses within hours, laying eggs that hatched into maggots at predictable rates, a technique modern entomologists still rely on today. But his innovations didn't stop there. To determine whether a victim had drowned, Song Sai described placing their bones under sunlight and sprinkling mercury on them. If the mercury pooled in certain patterns, it indicated water had entered the lungs before death, a principle eerily close to contemporary forensic lung flow tests. What makes the washing away of wrongs truly remarkable is its systematic approach. Song Sai emphasized examining crime scenes for minute details, blood spatter patterns, soil traces on clothing, even the angle of wounds to distinguish suicide from homicide. He debunked superstitions, urging officials to rely on physical evidence over coerced confessions. One chilling case study describes how he exposed a murder disguised as a suicide by noting the victim's sickle wounds couldn't have been self-inflicted due to their awkward positioning. Modern forensic experts have tested many of Song Sai's techniques with surprising results. His mercury test, though crude by today's standards, correctly identified drowning in experimental reconstructions. His observations on decomposition timelines align with modern entomological studies, proving his methods weren't just theoretical but grounded in sharp, repeatable observation. As we close this chapter on ancient forensic brilliance, our next discovery transports us to the bustling streets of Pompeii, where Romans engineered a clever solution to nighttime navigation centuries before streetlights. Now, let's step into the homes of ancient Pompeii, where the Romans engineered a clever solution to make their living spaces more comfortable centuries before modern double-glazed windows. In the 1st century, wealthy Pompeian villas boasted an ingenious form of insulation, windows with not one but 2 layers of glass separated by a thin pocket of water. This early double glazing wasn't just about keeping out the cold. It also muffled the noise of bustling streets, creating a peaceful retreat inside. Archaeologists studying these villas were stunned to find evidence of this advanced design. The Romans didn't just stack panes of glass, they carefully sealed the edges to trap water between them, creating a barrier that slowed heat transfer. On chilly nights, the water layer absorbed warmth from indoor fires, radiating it back into the room. During scorching summers, it helped block excess heat from entering. And because sound travels poorly through water, these windows also dulled the clamor of carts and crowds outside, making them a luxury feature in busy urban homes. What's even more impressive, modern engineers have tested reconstructions of these windows and found they reduced heat loss by nearly 30% compared to single-pane designs. A remarkable feat for ancient technology. Some villas even added dyes or crushed minerals to the water for decorative stained glass effects, blending practicality with artistry. This innovation didn't stop at Pompeii. Similar designs appear in Roman settlements from Britain to Syria, proving how widely this idea spread. While today's double-glazed windows use gases like argon for insulation, the core principle remains strikingly similar to what the Romans perfected 2,000 years ago. As we marvel at their ingenuity, our next discovery takes us to the arid deserts of Persia, where ancient engineers mastered another climate-defying trick, keeping ice cold in the blistering heat. Now let's journey to the sun-scorched landscapes of ancient Persia, where engineers tackled one of history's most daunting challenges, keeping ice from melting in the desert. Centuries before modern refrigeration, they built towering, dome-shaped structures called yakchuls, or ice pits, that defied the blistering heat with nothing but clever design and natural materials. These ingenious refrigerators relied on passive cooling, a concept so effective it's still studied by architects today. The yakchul's thick walls, made from a special mortar called saruj, a mix of sand, clay, egg whites, and goat hair, acted as insulation, blocking out the desert's relentless heat. Underground chambers, sometimes reaching depths of 20 feet, stored ice and perishables, taking advantage of the Earth's naturally cooler temperatures. But the real genius lay in the wind catchers, tall, chimney-like towers that funneled cool nighttime breezes downward, while the domed roofs radiated daytime heat upward, creating a continuous airflow that kept the interior chillingly cold. During winter, workers harvested ice from nearby mountains or diverted Kanat water into shallow pools where it froze overnight. They'd then haul the ice into the yakchul, layering it with straw or sawdust for extra insulation. Remarkably, this system preserved ice well into the summer months, even as temperatures outside soared above 100 degrees. Some yachtals could store up to 5,000 cubic feet of ice, enough to supply entire communities with chilled treats, medicinal ice packs, and even cooled drinks for royalty. Modern tests revealed just how advanced these structures were. Even in peak summer, the interior of a yachtal could stay a frosty 30 degrees cooler than the outside air, all without a single watt of electricity. Some were so efficient that ice remained intact for over 2 years, and it wasn't just Persia. Variations of these desert refrigerators popped up across the Middle East, from Mesopotamia to the Indus Valley. As we leave these ancient ice houses behind, our next stop takes us to the lush jungles of Mesoamerica, where another civilization turned nature's bounty into something truly revolutionary: waterproof fabrics that stretched like modern rubber. Now let's step into the vibrant world of the ancient Maya, where innovation wasn't just about survival, it was about transforming nature into something extraordinary. Picture this: a civilization thriving in dense rainforests, where rain was constant and humidity relentless. Yet the Maya didn't just endure these conditions, they mastered them. Over 3,600 years ago, they pioneered a textile revolution by creating the world's first waterproof, elastic fabrics, the secret. A brilliant fusion of materials straight from their environment. They harvested latex from rubber trees, a sticky, milky sap that's naturally water-resistant. But latex alone is brittle and cracks easily, so the Maya added a surprising ingredient: juice from the morning glory vine. When mixed together, these two substances underwent a chemical reaction that modern scientists are still unraveling. The result: a flexible, durable material that could repel water and stretch without breaking, essentially an ancient version of rubberized cloth. Archaeologists have found evidence of this fabric in murals and artifacts, showing how the Maya used it for everything from waterproof capes to sturdy sandals. Imagine warriors marching through torrential rains, their cloaks beading water like modern raincoats, or farmers working in flooded fields with shoes that kept their feet dry. This wasn't just practical, it was revolutionary. What's even more astonishing is how this process mirrors modern rubber vulcanization, a technique patented by Charles Goodyear in the 1800s. The Maya, however, cracked the code millennia earlier without the need for industrial tools. Recent experiments recreating their recipe confirmed its effectiveness. The morning glory juice acted as a natural sulfur substitute, cross-linking the latex molecules to enhance strength and elasticity. But the Maya didn't stop at clothing. They applied this knowledge to other innovations, like rubber balls for their sacred ball game, which could bounce astonishingly high. These fabrics weren't just functional, they symbolized a deep understanding of chemistry and material science, lost to time until now. As we marvel at their ingenuity, our journey takes us next to the rugged landscapes of ancient India, where another breakthrough in craftsmanship would leave its mark on history: diamond-tipped drills that could pierce the hardest stones. Now let's journey to the sun-baked plains of ancient India, where artisans unlocked a secret that would shape the future of precision craftsmanship. Around 600 years before the Common Era, while much of the world was still shaping tools from bronze and iron, Indian craftsmen were already harnessing the hardest material on earth: diamonds. These early innovators didn't just admire diamonds for their brilliance. They discovered something groundbreaking. When embedded into drill tips, these gems could cut through the toughest stones like butter. Picture a beadmaker in the Indus Valley, patiently rotating a hollow bamboo shaft with a diamond fragment at its tip, creating perfect, tiny holes in agate or carnelian beads. This wasn't just artistry, it was engineering on a microscopic scale. Archaeologists have unearthed thousands of these beads at sites like Mohenjo-Daro, each with holes so precise and uniform that they defy the era's technological expectations. The secret lay in their technique. A slurry of oil and diamond dust applied under steady pressure allowed the drill to grind through stone without shattering it. Modern experiments recreating these tools revealed their astonishing efficiency. Some ancient beads were drilled faster than what today's electric tools achieve on similar materials. But the real marvel, this technology wasn't limited to jewelry. The same principles were later adapted for medical trepanation, mining, and even early dentistry. Fast forward to the 1800s, when European engineers, struggling to bore through hard rock for tunnels and oil wells, turned to India's ancient diamond drilling methods for inspiration. Today, diamond-tipped drills are indispensable in everything from brain surgery to deep earth exploration, proving that sometimes the most advanced solutions are rediscoveries of forgotten wisdom. As we marvel at this intersection of beauty and ingenuity, our next stop takes us to the sun-drenched shores of ancient Greece, where a brilliant mind calculated the Earth's size with nothing but shadows and sheer intellect. Now, let's turn our gaze to the sunlit courtyards of ancient Alexandria, where a scholar named Eratosthenes accomplished something that would reshape humanity's understanding of the world. In the 3rd century before the Common Era, while most people still believed the Earth was flat, this Greek polymath did the unthinkable. He measured our planet's circumference with nothing but a stick, a well, and a stroke of genius. Here's how he cracked the code. Eratosthenes noticed that at noon on the summer solstice in Syene, sunlight reached the bottom of a deep well, meaning the sun was directly overhead. But in Alexandria, 500 miles north, a vertical stick still cast a shadow. By measuring that shadow's angle about 7 degrees, he deduced the Earth must be curved. Then came his masterstroke. If 7 degrees was 1/50th of a full circle, then multiplying the distance between the cities by 50 should give the Earth's full circumference. The result, his calculation of approximately 25,000 miles, was within 1% of today's accepted figure. But here's what makes it even more astonishing. Eratosthenes didn't have modern tools. He relied on bematists, professional walkers who counted steps along desert trade routes, and estimates from camel caravan travel times. Some scholars believe he even factored in the Earth's slight oblateness, a detail European cartographers wouldn't grasp for another 2,000 years. This wasn't just academic curiosity. His work enabled the first world maps with latitude lines, revolutionizing navigation. When Columbus set sail centuries later, he controversially ignored Eratosthenes' accurate calculations in favor of smaller, flawed estimates, a miscalculation that accidentally led him to the Americas. As we marvel at this blend of observation and deduction, our journey continues to the banks of the Nile, where another ancient innovation reveals itself not in grand calculations, but in the everyday chemistry of beauty and survival. Now let's uncover a surprising blend of beauty and science from the banks of the Nile. Ancient Egyptians didn't just wear makeup for aesthetics, they crafted it as a shield. Their iconic kohl eyeliner, made from crushed galena ore, contained lead salts that modern scientists initially dismissed as toxic, but recent research reveals a stunning twist. Those very lead compounds acted like a natural antibiotic, protecting wearers from eye infections common in the marshy Nile Delta. The chemistry gets even smarter. When sunlight hit the dark kohl around the eyes, it absorbed glare like a pair of primitive sunglasses. This reduced sun damage while enhancing vision in Egypt's harsh desert light. Archaeologists have found traces of these cosmetics in tombs dating back over 5,000 years, with recipes so precise they varied by social class. Royalty used finely ground malachite for green hues, while commoners mixed soot with animal fat. What's truly remarkable is how this ancient wisdom foreshadowed modern medicine. Studies now show the lead in coal triggers nitric oxide production, boosting the immune system's response to bacteria, a mechanism only understood in the 21st century. From Cleopatra's signature look to children's sun protection, this was pharmacology disguised as glamour. As we leave the world of ancient beauty secrets, our next discovery takes us to a playful yet profound innovation. where bamboo and childhood curiosity converged to inspire machines that would one day conquer the skies. Now, let's take flight with an invention that turned childhood play into a blueprint for the future. Over 1,600 years ago in ancient China, craftsmen were shaping bamboo into spinning dragonfly toys, simple gadgets that would one day influence the machines that rule our skies. These handheld whirligigs, when given a quick twist between the palms, would soar upward with surprising stability, mimicking the motion of real dragonflies. What makes these toys extraordinary isn't just their entertainment value, but the physics they demonstrated centuries before scientists fully understood aerodynamics. The bamboo blades, carefully angled and balanced, created lift by displacing air downward, the same principle that allows modern helicopters to hover. Fast forward to the Renaissance, and you'll find Leonardo da Vinci sketching his aerial screw design after studying similar rotational concepts, though the technology of his time couldn't bring it to life. Archaeologists have uncovered references to these toys in 4th century Chinese texts, where they were called bamboo helicopters or flying tops. Some were even decorated with painted patterns that blurred into colorful circles when spun, adding artistry to engineering. It's a striking example of how observation of nature, in this case the flight of insects, led to a prototype for human innovation. The legacy of these unassuming toys stretches all the way to the 20th century, when aviation pioneers like Igor Sikorsky studied their mechanics while developing the first functional helicopters. From a child's hands in ancient China to the rotors slicing through clouds today, this is proof that groundbreaking ideas often start as simple sparks of curiosity. As we marvel at how playthings paved the way for flight, our next discovery plunges into the streets of an ancient city where moonlight alone wasn't enough to light the way, until engineers devised a brilliant solution. Turning our attention from the skies to the streets, let's step into the moonlit nights of ancient Pompeii, where a clever innovation turned ordinary roads into glowing pathways. Long before electric streetlights, Roman engineers embedded polished white stones into their cobblestone streets, nature's reflectors that harnessed moonlight to guide nighttime travelers. These stones, strategically placed along busy thoroughfares, weren't just decorative. They were a practical solution to a universal problem: how to navigate a bustling city after dark without relying solely on flickering oil lamps. The Romans chose a specific type of volcanic rock called lucite, which had an almost mirror-like finish when polished. Under the soft glow of the moon, these stones would catch and reflect light, creating a subtle but effective illumination that marked paths and intersections. What's remarkable is how this system anticipated modern reflective road markings by nearly 2,000 years. Archaeologists studying Pompeii's ruins have mapped out entire networks of these lucite stones, noting how they were concentrated near theaters, taverns, and other high-traffic areas, proof that Roman urban planners prioritized safety and convenience. But the ingenuity didn't stop there. The stones were also slightly raised, providing tactile guidance for carts and pedestrians during rain or fog. This dual-purpose design reveals a level of foresight we often associate with contemporary engineering. While Vesuvius's eruption in 79 CE tragically froze Pompeii in time, it also preserved these ingenious moonlight streets for modern discovery. Next time you see a highway's reflective lane divider, remember, the Romans were there first, turning moonlight into a public utility. As we leave these glowing roads behind, prepare to cross one of history's most daring bridges, where grass became stronger than steel in the hands of Andean engineers. Now let's journey high into the Andes, where Inca engineers turned humble grass into one of history's most astonishing feats of suspension bridge building. Imagine standing at the edge of a dizzying canyon, staring down at a river hundreds of feet below, with nothing but a swaying walkway of woven grass connecting you to the other side. This was the reality for travelers crossing the Huachuca Bridge, a marvel of ancient engineering that still stands today quite literally because of a remarkable annual tradition. The secret lay in iku grass, a tough Andean fiber that locals harvested, twisted into ropes and braided into cables as thick as a man's thigh. These weren't just simple ropes, they were meticulously engineered to distribute weight evenly, with smaller cords interwoven to create a lattice strong enough to support armies, traders, and even llamas laden with goods. The bridges could span up to 150 feet across deep gorges, with stone anchors on either side holding the tension. But here's what made these bridges truly ahead of their time: they were renewable. Every year, communities would gather to rebuild the Seismoscope entirely by hand, using techniques passed down since the 1300s. This wasn't just maintenance, it was a living ritual that preserved ancient knowledge. Teams would work from opposite ends, weaving new grass cables midair without modern safety gear, relying on centuries of practiced skill. Modern engineers have tested these grass cables and found them comparable in strength to steel wire of the same thickness. The secret: the Incas understood something we often forget today, that flexibility can be stronger than rigidity. Unlike stone bridges that crack under seismic pressure, these grass structures swayed with earthquakes, absorbing shock like nature's own suspension system. Today, the last remaining Seismoscope bridge is more than a tourist attraction. It's a UNESCO-recognized testament to indigenous innovation. So next time you cross a modern suspension bridge, remember, the principles holding it up were mastered 6 centuries ago by engineers who worked with nothing but grass, teamwork, and sheer ingenuity. From these sky-high pathways, we descend next into the laboratories of medieval Islamic scholars, where a revolutionary chemical process would change medicine forever. Leaving the towering bridges of the Andes behind, we now step into the aromatic workshops of medieval Islamic chemists, where a groundbreaking discovery was bubbling to life. Picture this: long before modern laboratories with their gleaming glassware, a Persian polymath named Jabir ibn Hayyan was perfecting a technique that would transform both medicine and science: distillation. Jabir's work in the 8th century wasn't just about making stronger drinks, though his purified alcohols did pave the way for later spirits. His real breakthrough was in isolating medicinal compounds using a simple yet ingenious device called the alembic. This twin-chambered setup, often made of clay or copper, allowed him to boil liquids, capture their rising vapors, and condense them back into pure, concentrated forms. The result: some of the first essential oils, acids, and even early forms of antiseptics. What made this so revolutionary? For the first time, healers could extract potent remedies from plants with precision. Rose water for soothing inflammation, sulfuric acid for treating skin ailments, and yes, ethanol for disinfecting wounds. These weren't just incremental improvements, they leapfrogged past the crude herbal poultices of earlier eras. But Jabir's genius didn't stop there. He documented his methods in coded manuscripts, laying the foundation for modern chemistry itself. Centuries later, European alchemists would pore over his texts, borrowing terms like alkali and elixir that still echo in labs today. Here's the twist: while we often credit later scientists for medical breakthroughs, many were simply rediscovering what Islamic scholars had perfected half a millennium earlier. From perfumes to pharmaceuticals, Jabir's alembic set in motion innovations we still rely on. As we close this chapter on chemical mastery, our next discovery takes us to the battlefields of ancient Europe, where Celtic metalworkers engineered a wearable fortress. Now, let's turn our attention from the bubbling alembics of medieval chemists to the clanging forges of ancient Europe, where Celtic metalworkers were crafting something just as revolutionary: chainmail. Picture a warrior clad not in stiff bronze plates but in a flexible, shimmering mesh of interlocking iron rings. This wasn't just armor, it was wearable engineering genius. The Celts of the 3rd century before the Common Era didn't just stumble upon this design. Each piece was a meticulous puzzle with thousands of hand-forged rings, some solid, others riveted, linked together in alternating rows. The result, a suit that could absorb slashes, deflect arrows, and move with the wearer like a second skin. Unlike bulky breastplates, chainmail allowed warriors to fight on foot or horseback without sacrificing agility. But here's what made it truly ahead of its time. The Romans, masters of military innovation, saw its value and adopted it wholesale. By the time Julius Caesar's legions marched into Gaul, they were outfitted in Celtic-inspired lorica hamata, a testament to the design's superiority. Modern tests reveal why, when struck, the rings distribute force outward, reducing blunt trauma. Some surviving examples even show repairs, proving these weren't disposable garments but heirlooms passed down through battles. What's often overlooked is the metallurgical skill behind it. Celtic smiths had to balance hardness and flexibility, annealing the iron just enough to prevent shattering. Later medieval knights would spend fortunes on similar mail, unaware they were replicating a technology perfected centuries earlier. From the hands of Celtic craftsmen to the battlefields of empires, this was armor that changed warfare not with raw strength, but with clever, interlocking ingenuity. And as we leave the forges behind, our next discovery takes us even further back, to an ancient empire where warfare took a far darker turn. Now, shifting our gaze from the battlefield armor of Europe to the ancient strategies of the East, we uncover a far more chilling innovation: biological warfare. Long before modern germ theory, Chinese military tacticians were already weaponizing disease and poison with terrifying precision. Sun Tzu's Art of War, written around 300 years before the Common Era, doesn't just outline tactics for outmaneuvering enemies, it coldly documents the use of biological agents. Imagine a besieged city where wells, the lifelines of survival, were deliberately tainted with toxic plants or rotting corpses. Or worse, plague-ridden bodies hurled over walls by catapults, spreading sickness like invisible arrows. These weren't acts of desperation but calculated strategies to break resistance without direct combat. What's startling is how advanced these methods were for their time. Chinese generals understood contagion's psychological toll centuries before science explained how diseases spread. Historical records describe entire armies retreating not from blades, but from the stench of decaying bodies or the fear of poisoned water. Some sieges were won without a single sword clash, just the silent, creeping dread of illness. Modern analysts note the grim efficiency of these tactics. Unlike fire or siege engines, biological weapons didn't damage infrastructure, they preserved cities for capture while demoralizing defenders. But there's a dark irony here. These ancient warriors grasped the principles of asymmetric warfare long before the term existed, turning nature itself into a weapon. As we step away from these shadowy tactics, our next discovery transports us to a brighter realm, where ancient Egyptians turned the night sky into a precision clock. Turning from the grim tactics of ancient warfare to the celestial wonders of Egypt, we encounter a discovery that transformed the night sky into a meticulous timekeeper. The Egyptians didn't just gaze at the stars, they mapped them with such precision that their diagonal star tables, found in tomb ceilings, became the world's earliest known star clocks. Imagine standing in a dimly lit burial chamber around 1500 years before the Common Era, your eyes tracing the intricate grids painted overhead. These weren't mere decorations. Each diagonal row represented a specific 10-day period, and the rising of key stars like Sirius marked the passage of time. The night was divided into 12 equal hours, adjusted seasonally, a system so advanced it predated Greek and Roman timekeeping by over a millennium. What's fascinating is how practical these clocks were. Priests used them to time rituals, while farmers relied on them to predict Nile floods. The tables even accounted for the slight shifts in star positions over centuries, proving the Egyptians understood celestial patterns long before telescopes existed. Modern astronomers have confirmed their accuracy, with some star clocks aligning to within minutes of today's calculations. But here's the real marvel: these tables weren't just functional, they were a bridge between life and the afterlife. Egyptians believed the stars guided souls to eternity, making these clocks both scientific tools and sacred maps. It's a reminder that for them, time wasn't just measured, it was woven into the very fabric of existence. As we marvel at this union of astronomy and spirituality, our final discovery takes us to ancient Greece, where engineering met entertainment in the most unexpected way. Now, let's step into the world of ancient Greek entertainment, where engineering genius met theatrical magic. Picture this: in the 1st century, audiences at temples weren't just watching human actors. They were marveling at the world's first robotic performances, created by none other than Heron of Alexandria. This ingenious inventor crafted entire automated puppet shows using a clever system of strings, hidden weights, and even steam power. Imagine wooden figures moving on their own, doors swinging open mysteriously, and miniature scenes unfolding as if by divine intervention. Heron's most famous creation was an entire automated play about the myth of Nauplius, complete with moving ships and sound effects, all powered by a complex arrangement of ropes and rotating drums hidden beneath the stage. What makes these ancient automations truly groundbreaking is how they anticipated modern robotics. Heron used principles we still rely on today: counterweights for movement, steam for power, and precise mechanical sequencing to time each action. His designs were so advanced that when engineers recreated his devices in modern times, they found the mechanisms could run flawlessly for hours without human intervention. But here's the twist: these weren't just entertainment. Heron's robot theater served a deeper purpose in temples, where moving statues and automated miracles helped worshippers feel the god's presence. It blurred the line between technology and spirituality, proving that even 2,000 years ago, humans understood the power of mechanical wonder to stir emotions and belief. As we close this journey through history's most astonishing innovations, one thing becomes clear: our ancestors weren't just primitive, they were visionaries whose ideas still inspire us today. Looking back at these 50 astonishing discoveries, one truth stands out: human ingenuity isn't a straight line but a spiral. Time and again, we've invented, forgotten, and reinvented, proving that so-called modern breakthroughs often have roots stretching back centuries. The Antikythera Mechanism's celestial calculations, Damascus Steel's nanotechnology, Heron's robotic theater, each was a flash of brilliance that vanished, only to re-emerge millennia later. This isn't just about marveling at the past, it's a challenge to our assumptions. How many other revolutionary ideas lie buried in crumbling manuscripts or undiscovered ruins? Could the next leap in medicine, engineering, or energy be hidden in some overlooked ancient text? The Baghdad Battery hints at forgotten energy science, while Roman concrete's self-healing properties are only now being decoded. The cycle of loss and rediscovery reminds us that progress isn't inevitable, it's fragile. So here's my question for you: which of these historical wonders surprised you the most? Maybe it's the Inca surgeons performing brain surgery with obsidian blades, or the Chinese detecting earthquakes with bronze dragons. Drop your favorite in the comments, let's keep the conversation going. And if you're as fascinated by these echoes of ancient genius as I am, don't forget to like, subscribe, and hit that notification bell. Who knows, the next video might just uncover another piece of history's hidden puzzle. Until then, keep questioning, keep exploring, and remember, sometimes the future is buried in the past.